In this video, we're going to add and subtract terms that contain variables, focusing primarily on what it means to combine like terms. So the expression below contains something different than what we've seen before. We've seen variables potentially before, but we've always had values for them where we could substitute the values in and then move on. However, this time we do not, and basically what we want to do is we want to be able to simplify the expression below as much as possible. So before we start, let's look at changing all of our subtractions to addition because that makes those easier to work with. So we're going to use keep change here. So we have 5x plus 6y plus a negative 10x plus a negative 4y. And the big thing from here is that we can simplify this further and we can combine some things together, but we can only combine them together if they have what are called like terms. And a like term is a same variable part. So the idea behind this is that we don't know what this x value is, and we don't know what this y value is. We know that the y's have the same value and the x's have the same value, but we don't know if x and y are exactly the same. So all we can do is actually combine the x's together and combine the y's together. So here if you look, we see 5x and negative 10x. Those have a matching variable part. So when I say a like term, and that we're going to combine a like term, I mean it has an identical variable part. So here we see that we have x and x on both of those terms. As a result, they can be combined together using addition just like we did before. So 5 plus negative 10 would combine together to be a negative 5 times x. Then if we look at the next thing, we have 6y and a negative 4y. Those are like terms because they have an identical variable part of just y. So here we have 6y and negative 4y, which, if we add them together, combine together to be 2y, because 6 plus negative 4 is 2. So then from here, we are completely simplified. We've combined all like terms together. So when we are simplifying an expression, what we are doing is we are combining any like terms together. And that means combining anything with identical variable components. Now where this starts to get a little bit tricky is if we have things that contain like an x squared and an x. And the debate between, well, are those matching variable parts or not because they have matching variables. And the difficult part is because they are not identically matching, they are not the same. So x squared and x are not like terms. In order to be combined together with another term, it needs to have an identical variable part. X squared and x look different. Say, for example, that x was equal to 3. Well, that would make x squared equal to 9. So they are not the exact same value. They could be if x was 1, but they're not guaranteed to be. So what's going to happen as we add terms together is that we can only combine things with exact variable parts. So x's with x's, x squareds with x squareds. Now before we start combining, I'm going to go through and use keep change. So we have 2x squared plus 4x plus a negative 5 plus a negative 7x squared plus 4x. And then what we're going to do is we're going to look for like terms and combine identical terms together. So here we have 2x squared and a negative 7x squared. Notice those matching variable terms, the x squareds that they both have. So these combine together to be a negative 5x squared. Then we look onto the x's. 4x and 4x both contain just a singular x. Those are matching. So they can combine together to be 8x. And then this constant term with no variable piece, That we can leave on the end unless there are other constants in there that it can be combined with, which in this case it does not. So now we've combined together our like terms, noticing that x squared and x, because they are not identical, are not like terms. So a couple of formal notes here. When we are adding and subtracting terms that involve variables, the first thing that we want to do is we want to rewrite every subtraction using keep, change, change. Turn it into addition. Make your life easier. Then, after we've used keep, change, change, we want to combine all like terms together. And from here, just a reminder, like terms are terms whose variable part are exactly the same. X squared and x are not like terms. So make sure you get that into your head. If they do not have an identical variable part, they are not like terms and they cannot be combined together. So we're going to start simple here, and we're just going to combine like terms that we see in each statement. Now remember, our first step is to always go through and use keep, change, change. So we have 10x plus 5w plus a negative 7x plus a negative 12w. And then from here we identify our like terms. So I see a 10x and a negative 7x. Those combine to be 3x. And then I see a 5w and a negative 12w, which combine to be a negative 7w. And you can either write that as plus negative 7w, or you can write this as 3x minus 7w. Either answer will be accepted. Then if we look down at the second example, here we see, again, good places to use keep, change, change. Then we have 12x squared plus 4x plus a negative 9x plus a negative 10x squared. And we're looking for like terms. And remember, x squared and x are not alike. So here we have 12x squared plus a negative 10x squared. Those combine together to be 2x squared. We then have 4x and negative 9x. Those combine together to be a negative 5x. And then finally, this last problem. Here we can again use keep, change, change. So we have 16y plus 7y plus negative 10 plus negative 17. These first two terms both contain y's, so those are like terms. They combine together to be 23y. These second two terms, because they do not contain variables and they have no variable part, they are like terms, and they combine together to be a negative 27. So here now these are a little bit more complex. They contain more terms with more variables. But let's start just like we did before with keep, change, change. So we have 3y plus negative 5x plus 6w plus negative 4x plus negative 6y plus 3w. So here we have three different variables contained in the same statement. So I look at the y's first, and I see 3y plus negative 6y. That becomes negative 3y. I then look at the x's, and I see negative 5x and negative 4x. Those combine to be negative 9x. And then I see 6w and 3w, which is 9w. So yes, we have three variables, but it works out the exact same way. Now this next one here, again, we have some keep, change, change. So I have 4x plus 5x squared plus 6 plus negative 2x plus negative 6x squared plus 3x squared. So let's start by looking for like terms. And I see 5x squared minus 6x squared plus 3x squared. So that's a lot of x squareds, but let's start with just kind of combining them one at a time from left to right. So here I have 5x squared plus negative 6x squared, that's negative 1x squared. Then added together with the 3x squared, which totals to be 2x squared. So we just add them together from left to right. Then from there, we have 4x plus a negative 2x, so that's plus 2x. And then we have this constant term of 6 all by itself. So that just goes on to the end. All right, last one. Again, we have perfect instance for keep, change, change. So we have negative 3xy plus 4x squared plus a negative 8xy plus a negative 2x plus a negative 10x squared plus 3y squared. So lots going on here. So let's just start with the first one. So we have negative 3xy and negative 8xy squared. Those have matching variable parts of xy, so that becomes negative 11xy. Then I look at the x squareds, and I have 4x squared and negative 10x squared, which becomes a negative 6x squared. Remember, you can write that as subtraction or plus a negative 6x squared. Then from here, I'm looking at just x's, but I only see one term with an x, so I'm just going to write plus a negative 2x. And then I have one term with a y squared, so I'm just going to tack on plus 3y squared at the end.